Okay, let's continue the remaining two functions of this table. We have the leading term, which is 3x5. I want you to try and find as x tends to infinity, what is f of x? And as x tends to negative infinity, what is f of x? See if you get the same exact answer. If your answer, I'm showing, matches the graph. Same with the second one. Find the end behavior. And if you do have any questions, make sure to ask them in class. Now let's have a look at this function. Remember, we took 4 different cases. They're asking us to describe the end behavior and determine a possible degree of the polynomial function. Now, the first thing is we have even or odd, right? And with even, we're going to get 2 cases, if k is positive or k is negative. And with odd, we also have 2 cases, if k is positive or if k is negative. Now, if k is positive and even, let's write down a case. So let's say we have x squared. K is positive, k is 1. It's even. Now, let's first determine as x tends to negative infinity, what do we get? As x tends to negative infinity squared. This equals to infinity, which is definitely not the case. As x tends to negative infinity, we're searching for f of x, which equals to negative infinity. So this one is out. Now what about the second? If k is negative, we have negative x squared, even k is negative. Now let's first determine as x tends to negative infinity. Are we going to get negative infinity? Well, negative of negative infinity squared. This is negative infinity squared, which is negative infinity, which does work. Just need to determine the second one, as x tends to infinity. Is f of x equal to infinity? Well, I have negative x squared as x tends to infinity. What do I get? I get negative infinity squared, which is negative infinity, which is not the case. So even is not the degree. It's going to be odd. Let's just determine whether k is positive or negative. Let's say positive x cubed as x tends to infinity. Negative infinity. Will I get f of x equal to negative infinity? Let's see. Well, negative infinity cubed is in fact equal to negative infinity multiplied by negative infinity multiplied by negative infinity, right? Now, since it's cubed, what happens to the sign? It remains as it is. So we have negative infinity times infinity times infinity is just infinity, right? So negative infinity cubed equals to negative infinity. Now, let's determine whether x tends to infinity. Do I get f of x equal to infinity as well? Well, as x tends to infinity, we also do get infinity cubed, which equals to infinity, which does mean k is positive and it is odd, and that's it. Just need to determine which case would match this graph, and yeah, that is pretty much it. Let's move on to the next one. Let's say, I want you to describe the end behavior. We have as x tends to negative infinity, f of x equals to negative infinity, right? And as x tends to infinity, f of x equals to negative infinity as well. So what I want from you is to write down the cases. We have even or odd, right? And with every single case, k could be positive or k could be negative, and then k could be positive or k could be negative. You first test this case. If it works, it works. If it doesn't, then you test this one, you test this one, and then you test this one. And determine what's a possible degree? So what I want from you is to test the first one, which is x squared. Then you test the second, which is negative x squared. You test this one, which is x cubed. Then you test this one, which is negative x cubed. You see which case would give you this graph or this function. Okay. Let's move on to this one. Given the following function, express the function as a polynomial in general form and determine the leading term, degree, and end behavior of the function. So how do we do this? You just need to distribute the function. You need to FOIL it. So negative 3x squared multiplied by x minus 1 multiplied by x plus 4. We have negative 3x squared. You keep it as it is. You work on this. We have x squared plus 4x minus x minus 4. Negative 3x squared, x squared plus 3x minus 4. You distribute the negative 3x squared, you can get negative 3x4 minus 9x cubed plus 12x squared. And that's it. This is simply your polynomial function in general form. What is the leading term? The leading term is the term with the highest degree, which is negative 3x4. What is the degree of this function? Degree equals to 4. Now, what else do we have? How do I find the end behavior? You take the leading term and you first plug in infinity or negative infinity, it's up to you. So negative infinity, we have negative 3. Negative infinity 4 is equals to infinity, right? Because the 4 will cancel out the negative, and infinity times itself 4 times is just infinity. Negative times infinity is negative infinity. Now you do the same for positive infinity. We have negative 3, positive infinity 4. This is just negative 3 times infinity, which equals to negative infinity as well. Trying my best to finish this video before the battery runs out. We're at 4% in case you can't see it. And okay, how do I determine the y and x intercepts? Well, we know how to find the y-intercept, right? Same with the x-intercept. You just, y-intercept is placing the function equal to 0. I'm sorry, what did I just say? Y-intercept is plugging in 0 for x, right? This is y-intercept. X-intercept is placing the function equal to 0 and finding the x's. Okay. And yeah, let's understand this with this example, example number 8. Given the following polynomial function, it's written in factored form for our convenience. We just need to determine the y and x intercepts. How do I find the y-intercept? Remember, y-intercept means plugging in 0 for x. So 0 minus 2, 0 plus 1, 0 minus 4, plugging in 0 for x. Negative 2, 1, negative 4, it equals to 8. That's it. Now, how do I find the x-intercepts? You take the function, you place it equal to 0. You have x minus 2, x plus 1, x minus 4 equal to 0. You have x minus 2 equal to 0, x plus 1 equal to 0, and x minus 4 equal to 0. So what does this tell us? It tells us that x equals to 2, x could be equal to negative 1, or x could be equal to 4. So these are the 3 x-intercepts. All good? Now let's have a look on the graph. Let's see what this looks like on the graph. These are the x-intercepts, and the y-intercept is simply this point. Now, what are these 2 points? These are called turning points. When a function is increasing, then it decreases, or when it's decreasing and then increases, that point would be called a turning point. Now, last but not least, this is a really cool trick to understand how many x and y-intercepts, how many x-intercepts and turning points do I have in a function. Let's say f of x equals to 3x4 plus 2x squared. Now, what's the degree of this function? It equals to 4, right? Degree equals to 4. Now, since the degree equals to 4, at most, this function can have 4 x-intercepts. That's the highest number of x-intercepts. It can have 1, it can have 2, it can have 3, or it can have 4 x-intercepts, but it cannot have 5 x-intercepts because the highest degree is 4. Now, what about the turning points? You take the highest degree, which is 4, you subtract it from 1, 3, and this is the most number of turning points this function can have. It can have 1, it can have 2, it can have 3 turning points. It doesn't matter which is greater, the number of turning points or the number of x-intercepts. Let's say this function has 3 turning points, and it can have 2 x-intercepts. That's totally fine. As long as the number of x-intercepts is less than the number of degree, and the number of turning points must be just equal to, the number of x-intercepts can be equal to the degree, and the number of turning points must be one number less than the degree in this case, okay? Now let's have a look at example number 11 and understand this a bit more. What can we conclude about the polynomial presented by the graph shown based on its intercepts and turning points? Well, it does have 2 x-intercepts, and it has 1, 2, 3 turning points. And what is turning points equal to? It's n minus 1, right? So n minus 1 equals to 3. Now what is n? N equals to 3 plus 1, which is 4. Now n is the degree of this function, right? So n could be equal to 4, or it could be equal to 5, or it could be equal to 6, and so on and so on. So let me give you an example. x4 plus 3x squared. Now, what is the number of turning points? If I do 4 minus 1, that is 3, which is fine. And 2, the number of x-intercepts, is less than 4 or equal to 4, which is also fine. And let's say you just look at the number of x-intercepts and you forget the turning points, right? Let's say you do, well, it has 2 x-intercepts, then you might be like, oh, well, it's just x squared plus whatever, let's say x. Well, this is fine with the number of x-intercepts, which is 2, but it's not fine with the number of turning points, because number of turning points is, remember, degree minus 1, which equals to 1. And in this case, the highest number of turning points can be equal to 1, and I have 3 turning points, which is definitely not the case. So yeah, I suggest you always take the highest number, whether it's x-intercepts or turning points, and then you can determine what is the degree of that function. So let's say in this case, it has 2 x-intercepts and 1 turning point. I would look at the x-intercept. And since the number of turning points is greater than the number of x-intercepts, I'm looking at the number of x-intercepts, okay? So yeah, that is pretty much it for example number 11. My battery is at 2%. So let's have a look at the final question, and then and I'm going to send you some homework that you can do on your own after watching this video. So example number 12, given the following function, determine the local behavior. How do I do this? Well, you just need to distribute, and once you distribute, you determine the x-intercepts, the y-intercepts, and the turning points. So x-intercept, y-intercept, and turning points is simply the local behavior of example number 12. And my battery is at 1%, so I'm going to stop the video right now. If you do have any questions, make sure to ask them in class. Thank you. We'll see you. Bye-bye.